Configuring and applying standard access control lists. That title says it all. Let's get started. You might remember me saying in the previous nugget that the only way to get access lists down is by doing them again and again and again. It's like subnetting. So that's what I've done here, is created a scenario of standard access lists in this case that we're going to work through. But before we dive right in, I want to go through and just familiarize ourselves with this whole network diagram. First off, left-hand side, you can see we've got the 192.168.1 network. So we've got a computer on there, 192.168.1.50. Default gateway is 1.1. And then we've got a WAN link. Now we've gone to a /30 subnet mask on here. So again, practicing our subnetting skills, sometimes you're going to look at that and say, okay, well, what is that range? What IP addresses are in there? Now, in this case, it's easy, especially if you have experience looking at a /30, because you know there's only two IPs and they're assigned on each side. But let's say you didn't. What you would do is say, okay, well, /30 as a decimal subnet mask, what is that? Convert that back to decimal. So that would be a 255.255.255.252. Now, some of you might say, well, how'd you know that? Well, it's just because I know. But when you take 30, essentially that means there's 30 ones in the subnet mask. So that's 8 ones, 8 ones, 8 ones, 6 ones right there. So add them all up. And there's your 30. So that will be where you get the 252, is by putting your 6 ones, that's 6, like that. Now, the good news is that also gives you your increment. Remember, lowest network bit as a decimal is a 4. So I'm going to be able to reverse engineer my ranges. They would have had to start at 10.1.1.0, .4, .8, .12, down they go. So fill in the n ranges. And now I've, not written that right. Now I've reverse engineered what we've got here. So this one is 10.1.1.0 through 3. Can't use 0, it's a network. Can't use 3, it's a broadcast. So 1 and 2 are the usable IP addresses from there, right? So that explains our WAN links. So our WAN links are being very efficient. We're actually using VLSM in this scenario, variable length subnet mask, changing the subnet mask based on the fit. So what's up with this? Well, I put this on there, this /25 at both of these locations, because you will run into that subnet mask in the real world. A lot of people use it. It's very efficient. But also because I really want to show you how wildcard masks work, which is what ACLs really thrive on. So seeing this, you might say, okay, well, explain that to me. How do we do that? Well, same thing. A /25 is really 255.255.255. That's 8 plus 8 plus 8. That's 24 ones so far we've got. So 25 ones would be 128, right? So essentially 1000000 is what that comes out to. So this as a decimal number, that's our increment, is also 128. One of those nice weird ones where the subnet mask equals the increment. So looking at our network, that means we've got 192.168.2.0 is where it begins. .2.128. Now what do you get if you add 128 to 128? 256. So fill in the n ranges. And there's our two ranges that we go, okay, so we really have broken a Class C network into two subnetworks. One of them going from 0 to 127, that's this one. So default gateways .1, he's .50. The second range going from 128 to 255. Again, can't use the first one, can't use the last one. So you notice on this side, I kind of drew through it, the default gateway is .129, the first usable IP address from that range. And this computer just happens to be another one in that range, .150, right? So good. I mean, that's really good because to truly get access lists in all their glory, you have to be one that understands the subnetting behind it. Okay, so that's what we've got so far. Now, what I've done is I've actually set up this little scenario in GNS3. Now I do these series totally out of order, so I'm actually recording this access list nugget before I've done routing. Why? Because I just wanted to record access lists. So I don't know if I've shown you GNS3 yet, but if I haven't, this is GNS3. CPT Nuggets, actually, Keith Barker just released a total series on how to use GNS3. It is a free emulator for Cisco. So just in case I did mention this earlier, I won't dive into it in all its glory. But this is the topology that we've set up. These are essentially running the real Cisco iOS. That I'm using a 2691 platform. if I could keep that little thing there. 2691 platform. I've just found that to be a really stable with 12.4 iOS on there. So we have this environment running. Last piece I'll add on the setup of it all is I've gone in and set up. I'll do a show IP interface brief on router 1. I can see the interfaces. So again, router 1 is this guy, upper left corner. We can give me my terminal back. Bring the terminal so we can see, and I see fast Ethernet 0/0, 192.168.1.1, that matches. Serial 0/0, 10.1.1.6, that matches, and I'm able to verify that. But I've also set up RIP. This is just a base config on there. I'm going to do a show IP route, and you can see that router 1 knows how to reach all of the networks in our little mini enterprise here. So he's able to reach 192.168.2.128. So I can ping, or that network, so I can ping 192.168.2.129, excuse me. So this represents the network. I'm pinging the default gateway. That's this guy on that network receiving successful. So as a foundation, we have full IP connectivity. Okay, if you were watching closely, you just saw the whole scenario for number 1 change. And that's just because I started getting into it. I'm like, this is just too, we can do it. It was just the old one I had up there just a second ago was too complex for example number 1. So I changed it a little bit. So let's get into it. Before we configure an access list, recall to your mind, there are 2 distinct phases of access list setup. Number 1 is configuration. We need to go on the device and set the access list up. This is done from global configuration mode, and we put in our list of permit and deny statements. But we can do that all day. We can create 1,000 access lists, and it will never do a thing until we hit step 2, which is application. And this is where the action really happens. I mean, if you're thinking about, I don't know why this came to my head, but when you were a kid and you built those little Matchbox race cars, you can build them all day, but until you put them on the ramp and say go, they're just going to sit there and look pretty, and that's all these access lists do. And the application is where all the action happens. We're going to be applying it in terms of security, but keep in mind we can apply this in terms of quality of service, in terms of VPN. This is just a list, a way of matching stuff. So how we apply it says what that matching will then do to all of that stuff. So we are set from a goal of saying I want to block 10.1.1.1, that is router 3 right here, from reaching 10.1.1.6, that is router 1 right there, and 192.168.1.0/24. So this whole network. So I'm saying I want to block him from coming over here and reaching him or those networks. So envision with me, we're going to build a wall here to block that guy from coming over here. Now, I know you're probably like, okay, it makes sense. I don't really need the picture. But you do, because even though we first go in and configure the access list, you're in global config mode when you do it, you have to already be thinking ahead. It's like a game of chess. You got to be 2 steps ahead thinking, okay, I'm going to set this up, but where am I going to apply this? Now let's think about a standard access list. Standard access list filters only on IP source information, right? Think this through with me. IP source address information. So based on who you are. So for instance, this guy says, hello, I'm 10.1.1.1. That is all we can filter on. I can say, okay, 10.1.1.1, you are denied. And he goes, thanks. I mean, well, what do you say to that? I mean, well, denied from what? Well, it depends where we put this access list. And this is where we got to be careful. You might say, well, we want to catch it right here. I want to block 10.1.1.1 from reaching those networks. So let's block him right here as soon as he tries to get in router 2. And you're already thinking in terms of direction. So as he's coming in, because we're going to have to apply this in a direction to router 2, I want to block him, right? Well, careful. If I do that, and I can just say 10.1.1.1, you are denied from coming in to router 2, what have I blocked him from? I can't reach this. Can't reach this. He can't reach this. He can't reach this. I mean, yes, did I accomplish my goal? Yes. But with a sledgehammer, it's like saying, oh, let's just take him out from everything. And that's not what the scenario said. Scenario didn't tell us to block it from here and here and here and all that. It just said block it over here. So Okay, what that tells me is since we are only able to match based on the source, right? Are you following me here? Since I can only say 10.1.1 is denied, then I got to go as close to the destination as I possibly can. I'm probably going to go, matter of fact, I'm probably going to create this right on router 1. And I'm going to apply it, as they're coming in this interface, because that, then I can say you're denied and not deny them from too much. That accomplishes my objectives, right? I can say you're denied because now you won't be able to reach this, nor will you be able to reach this. But that access list doesn't exist until we get there, so you can access everything in between. So let's do this. I'm going to bring up router 1. No, I'm going to bring up router 3. And I want to, before we do anything, we've got to know what we've come from. I'm going to make sure that I can ping to this. Matter of fact, I'm going to telnet to that. I'm going to make sure I can ping this IP address. Just make sure everything's working, because if you don't know what you have beforehand, you don't know if you accomplished anything. So let's go here. I'm on router 3. Enable, let's do a show IP interface brief, just orient ourselves. I see there's my fast Ethernet, life is good. Okay, there's my serial. So I'm going to ping. Let's do a ping to 10.1.1.6. We are good. We're humming along. Ping 192.168.1.50. So I am... Okay, that's not as good. I'm glad we tested this. So hang on, let's do a show IP route. I want to make sure that I can get there, 10.1.1. So it says I know how to reach the 10.1.1 network. So let's go over to router 1. I bet you I forgot to configure that PC, but let's find out. Show IP interface brief. I just want to make sure the interface is up. Okay, so let's try from here. Ping 192.168.1.50. Oh, Jeremy, you forgot something completely. You know what? All these PCs, so these PCs, they're not really PCs. They're actually routers that I made to look like PCs. And I completely forgot to give them a default gateway. And they're not running RIP. They don't know how to get out. So here, hang with me. Let's do this on the first one. That's a good troubleshooting technique. So I'm going to open my little PC1, show IP interface brief. It's got an IP address, but when I do a show IP route, it's like, I don't know anything. I don't have a default gateway. I don't have anything. So watch this. Let me show you how to reduce a Cisco router to like a nothing. This is like insulting to a Cisco router to do this. I'm going to do no IP routing. I pretty much said, yes, you are a router, but you cannot route. You're not really routing, because I'm just going to make you like a host. I'm going to do IP default gateway, and we'll do 192.168.1.1. There we go. So now I'll do a show IP route. Notice it totally changed. It's like, I used to be able to do all this, but now I am a nothing. I can't get anywhere. All I know is my default gateway is this. I've reduced this router to essentially a PC. So I'm going to save that in the config files, because I'm actually going to make these GNS3 config files available to you, so you're able to try this out. And like I said, practice makes perfect on this. So I'm going to get in here and do the same. Let me pause it. I'm just going to do the same thing for PC2 and PC3. All right, that's done. So now it should work. Let's go back to router 3, and I'll just hit the up arrow. It failed before, but should work now. Okay, worried me for a second. Okay, there we go. So we've got router 3 now able to fully ping. So this verifies router 3 is able to get here. He's able to get all the way to PC. Let's just do one more test, because I'd like to check this out as well. I'm going to even telnet 10.1.1.6. It comes up, says you are there, so I am telnetting from, I just telnetted from router 3 all the way to router 1, and shows we connected, and we are good. So we have verified IP connectivity, and now let's get into the access list. This access list, based on all the chicken scratch on the screen, I'm going to create on router 1. So let me just wipe off all that. Okay, I'm going to create over here on router 1 so that I can block those coming over. So I'm going to first on router 1, not router 3. Let's go to router 1. Go into global configuration mode and type in the command access list followed by a question mark. And by the way, if you haven't gotten used to using your question mark, now's the time. A question mark through the access list is almost critical. So you can see right away the Cisco router is like, well, okay, you said access list. What kind of access list would you like to create? Now you see in this list, there's a whole bunch of them, but most of them, you're like, okay, I'm not going to use that. I'm not going to create an AppleTalk access list, IPX access list, DECnet. I mean, these are protocols we just haven't seen for decades, or I would say at least a decade, because TCP/IP has replaced them all. The main one that we care about is right up here. Standard and extended, just what I was mentioning in the last nugget. So based on the number I type in, the router knows what kind of access list I create. So if I type in, for instance, access list 5 and start configuring my options from there, the router knows I'm creating a standard access list, and it will give me one set of options, versus if I put 105, it knows I'm creating an extended access list. This is going to give me a totally different set of options. So in here, we're going to focus on standard. So I'll do access list. Let's just start with 1, right? Now, a list, I'm creating my access list, can contain as many statements as you want. So I have a list 1, but it could contain many of them. Also notice, so you say, okay, so I can create 99 access lists per router, right? Well, yes, that was in the original version of the iOS. That's the limit, but I've never seen a router with 100 access lists on it, but I'm sure they exist out there. And because of that, you can see that Cisco has come up with an expanded range. So they say if you run out of numbers, 1 through 99, there's 600, 700 more that you're able to use. Same thing right here, expanded range for the IP extended. But all that being said, I'm also going to show you this later. You can also use named access lists. So instead of using a number, I can say access list deny Bob or something like that, and create as many of those as I want. So I hit the question mark, and it's saying, okay, you are now configuring your first statement in access list 1, your first line entry. So I'm going to say, okay, well, what I wanted to do is I wanted to deny somebody. And I hit the question mark, and it says, okay, well, who do you want to deny? Do you want to deny anybody? Do you want to deny just a single host? Or is there a specific address that you want to match here? And so I'm looking here. I'm like, okay, well, actually, there's actually a couple ways I could go about it. I'll do one way first. I'm going to deny 10.1.1.1. Now it's just that one host. I mean, that's my whole focus right now, is that one host. So I'm going to take the easy route, and I'll show you why in a little bit. I'm going to type in deny host, a single host address, and they are 10.1.1.1. You see how this question mark is so critical? So now it says, okay, well, if you want, I can also create syslog messages anytime this host is denied, so you know that they're being denied. Or you can just press the enter key. Now, I'll say most of the time, unless you're really interested if that host is denied or not, there's other ways of verifying that. I'll just press the enter key, because the more logs you put on there, the more it's going to start filling up all your memory buffers and syslog servers with all these entries saying this guy's denied, this guy's been permitted. So, ta-da! We've created our first line in our access list. So I'm going to type in the command from privilege mode, show IP access list, and it's like, hey, you've now created list number 1. Inside of there is deny 10.1.1.1. And now the Cisco router added this to the front. What's that? It's sequence 10. You're going to find out that the Cisco router allows us to squeeze entries in. So for instance, the next line that I add by default, unless I change it, is going to be sequence 20, sequence 30, sequence 40. The more lines I add, I have these sequence numbers. So what I can do is come in and squeeze things in. So I create 10, deny this person, 20, permit that person, 30, deny that person. And all of a sudden I'm like, oh, I forgot. I wanted to put one here. Now in the old days, when I first got into Cisco, there was no sequence numbers. If you had to squeeze something in, you had to delete the whole access list and recreate it. Yeah, seriously, it was painful. But now I can just say, well, I want to squeeze in sequence number 15 and put a line kind of in between those, so I can change the order of the events. So let's continue on from there. So is this guy ready? Can I just apply this? No. That would run into one of the most common devastating events that you could do with an access list. Here's access list 1, right? We've created our first list, and we've said sequence 10 is deny 10.1.1.1, right? And that's the only thing that's in there. Now think back to the last nugget. What is at the bottom of every access list? I said in the last nugget, I said you won't see it there, but it's there. Anyone remember? Yeah, you. Yeah, okay, you in the red shirt. Deny everything. You got it. Deny everything. So if in this, let me make a statement. This is a key statement to remember. If you have an access list that just has deny entries, it is an access list that will completely cut off all network connectivity if you apply it. You must have at least one permit statement in there, or else you might as well unplug the cable. I mean, if I were to take this and now apply it to this interface inbound, it would say, okay, I'm going to deny this person, and then I'm going to deny everybody else. You might as well shut the interface down, because that's exactly what you've done, and that's so easy. I mean, in a quick move without thinking it through, sometimes you're like, oh man, we're under attack because a new SQL Slammer virus worm came out today. Let's go out and deny this source IP address from China or wherever it's coming in from. This attack originated, and so you quickly say, oh, deny this, and then you go apply it, and well, I would say you're safe. You've protected yourself because you've completely cut off the internet connection, which is probably not what your intentions were. So what we need to do is add in a permit. So let's think this through. What if I'm denying this one, then what am I permitting? Well, everything else, right? I mean, this shouldn't be impacted. This just said deny that and that alone. So I want to permit everybody. Okay, well let's go back there. There was actually, did you see the keyword in there for that? So let's add line number 2. So I'm going to say access list 1, and now we're going to say, okay, permit. Anyone have a guess what keyword? Any source host, right? So check this out now. I'll do a show IP access list, and right there I can see access list 1 now has 2 statements. See how this is building? Statement 10 says deny that person. Statement 20 is permit anybody else. Now you might think, okay, well, so what about the implicit deny at the end? Well, now that we've put a permit all before it, we'll never get there. Remember, the rules of an access list is as a router, so as packets are coming in, the router's going to now filter them and say, are you this person? Because if you are, you're denied. Okay, if you're not this person, you hit this permit all statement. Now, as soon as it gets the first match in an access list, it stops processing. So for instance, if 10.1.1 did come in there, it's not like it goes, okay, well, I'm going to deny you, but no, actually, I'm not going to deny you because I see right next to me is a permit everybody, and you're kind of like everybody, right? So let's no. As soon as you get your first match, it says, check, I'm not looking at any more of the access list. So the good news is by putting in a permit all, I've really reversed the whole mindset of an access list. I've now said, deny what I say to deny, but permit everything else. Sometimes you'll hear people call this. I've heard this said once. I thought it was a great way to describe that. This is like fishnet security, where you're allowing all the water to go through, and you're trying to catch the big old fish. Which in this case is 10.1.1.1. Everything else can go through those giant gaping holes in the access list. Whereas leaving the deny all is like iron wall security, and you've got a little drill, and you say, I'm allowing this, port 80 through. I'm allowing 10.1.1.1 through, or whatever you're allowing through. You just kind of poke these little holes and go through. Which is better? This one. Sorry, back up. Let me use the universal. It depends. It depends on what you're trying to accomplish, but most of the time, if you're talking about like internet security, the iron wall. Just saying exactly what is allowed in is usually the best way to go. Okay, so we've got this access list created, right? Woohoo! We're in global config mode. We're going back to those 2 things. Step 1, the config is done. We're ready. But now we have to go to the application. Now, in this case, I need to go into the interface where I want to apply it. And in this case, it's serial 0/0. Now I said right here, assume all Ethernet ports are fast Ethernet. So this is fast Ethernet 0/0. Could I apply it here? Yes, but it would miss one of the objectives. So let's apply it here first. So I'm going to go on router 1. And I'm going to say, okay, I want access list 1 to take effect, global config mode, interface serial 0/0. And I'm going to use the command. Here's the command. It is IP access group. Why'd Cisco do that? Because it's just they had to have a different way. So IP access group is how we apply an access list to an interface. It's not IP access list. It's IP access group. I hit the question mark, and it says, okay, what number of access lists would you like to apply, or even what name if you've used the name one. I'll show you how to do that in a moment. So I would say I want to use number 1. That's the one I created. Now it's going to ask me that key question. Remember I said last time you got to get this one right. Inbound or outbound? Okay, how do I determine that direction? Be the router. I am router 1. My right arm, again, if I'm a human being, my right arm is serial 0/0. My left arm is fast Ethernet 0/0. So I'm holding them out right here, and I go, okay, direction wise, I'm applying it right here. Am I filtering traffic in as it's coming into me from my right arm in the serial 0/0, or am I applying it out to where it's going out this interface? If you think that through, it's in, because router 3 and everything else is going to be coming in my arm, in the interface to me, the router sitting in the middle, and that's where I want to do the filtering. So I'm going to say apply that inbound. All right, let's do I'm going to do a show IP. You can actually type in show access list, but the reason I like show IP access list, they're the same exact command, is because I can hit the tab key after 3 letters and it fills it all in. Whereas if I do show IP or show access, I actually have to type in the dash and the L, and then it works. But it's same exact command. Now, checked it out. We've got deny 10.1.1.1, it's there, but it hasn't done anything yet because I can see below the permit any is getting 3 matches. So there's already 3 packets that have come in and said, I want to come in. And the access list says, okay, come on in. They might say, well, Jeremy, you're talking. What's going on? Why is there matches coming in? Well, remember I said at the beginning, I set up RIP, a routing protocol, which is saying, hey, I know about these networks. So it's sending its little updates behind the scenes. So chances are, I hit the up arrow, it's now up to 6 matches. So RIP is talking and chatting and sending its route updates, doing its thing. That's the matches that I'm getting. Okay, let's test it. Let's go over to router 3. Who is this guy? Over here, right? Router 3. And now, we tested before that I was able to ping. I could telnet to this guy. So let's try it now. Ping 10.1.1.6. Denied. Matter of fact, you can see right here, use. That means unreachable, as in a protocol called ICMP has come in and said, you are being blocked. Usually when you see a U, that means either the router has no idea what you're talking about, it doesn't have a route to that destination, or an access list is blocking you and sending back messages saying you are being denied. Now, when you get into if you decide to go security as your specialty and get in there, one of the things that you'll learn is a way to turn this off. Because as a hacker, if I'm trying to hack in somewhere and I do a ping and I see U's coming back to me, that tells me something. That tells me they are alive. I can get there, but they have purposely put an access list on there that is blocking me. There is a command that you can do to turn off what's called ICMP unreachable messages. So that way it just says dot. It's as if you would have pinged just an IP address that doesn't exist. Dot. You can't tell that you're being blocked. So that's in the security series. So I'll leave that to them. So let's do some more testing. I'm going to try and telnet. We just did that up here, right? Telnet 10.1.1.6. Telnet to 10.1.1.6. Denied. Destination immediately comes back unreachable gateway or host. I'm being blocked from there. Now, okay, so that verifies that I can't get here. Now, what about this guy? I could ping him before, so let's do a ping 192.168.1.50. Successful. So now let's go up here to router 1 and hit the up arrow and do the same command. Ooh, check it out. Now we can see it in action. We're denying 10.1.1.1 25 matches from all the pings and the telnets and everything else I'm trying to do to reach that. It's actually saying I'm blocking. Okay, awesome. That is excellent. Now let me do this. Wipe. I want to go back to the question I said. Could I apply it right here? Yes, I could apply that same access list right here. Matter of fact, let's do that. I'll go into interface serial 0/0, and I'm going to do no IP access group 1 in. So I'm taking it off of the serial port. So, I mean, immediately upon doing that, I should be able to hit the up arrow, and now my pings are going through successfully. You can see access list in action right there. But now, let's say I went into fast Ethernet 0/0, and I said, okay, well, I want to apply it here. Well, first off, let me ask you, what direction would you apply it? Okay, B the router. This is fast Ethernet 0/0. This is serial 0/0. I've got access list 1 that says deny this guy, holding my arms out. If I apply it right here, I want to apply it outbound, like as it's going out router 1. Because if I apply it inbound, what would that mean? It would assume that 10.1.1.1 is over here somewhere. trying to come in. That's not the truth. That's not where it's at. So it's going to be applied outbound there. And let's do it because I just want to show you. I'm going to go under fast Ethernet 0/0. Let's just hit the up arrow. Ooh, wait, stop the train. Moving too fast. I just caused an internet outage. So IP access group 1 outbound. So I've applied it in the out direction on fast Ethernet 0. Now, can I go to router 3 and test? Yes, I can. If I find them. Router 3, I'm going to hit the up arrow and ping him again. And okay, that's good, right? It means I'm blocked from getting to this guy. I just tested that, but what's missing? If it's applied outbound right here, then getting here, which is one of the objectives, block him from reaching it, it's not going to be there because I've removed it from this. So he's going to have no problem reaching this. It's just when he tries to go out right here is where he's going to be blocked. So let's just verify. Ping 10.1.1.6. Good. So again, verifying that this was indeed the correct place to put that access list. All right, let's look at number 2. Use a standard access list to block access to the 192.168.1.0/24 from 192.168.2.128/25. Now, again, why it's so critical to draw this out is just so you can visualize what's going on. So what it's saying here is not to block this specific IP address. It's saying block this whole network. So 192.168.2.128/25. So that's identifying the whole. Remember, the 128 is the network ID. So I'm saying the whole network is being blocked from accessing this whole network. So again, big sweeping statements there. Okay. So let's do that. First off, I'm going to go into. Okay, before I even do that, let's figure out where we're at. Right. Again, standard access list only blocks based on IP source. So I can't really say what something is denied from other than where I apply it to. So if I create an access list, again, apply it here as things are coming into that interface, then I've cut off too much. So again, I'm back over on router 1, and I'm saying, okay, well, I need to block, no longer am I blocking access to this. I need to block access to this subnet. So I need to catch things as they're trying to leave this interface. Again, with standard access lists, it's as close to the destination as possible because the closer you move to the source, the more chance you're going to block too much since you can't really say what they're denied from. You just say they are denied. That's just based on the source. So, okay, so I'm going to be right here as they're going out, right? That interface, I need to block them. So I'm back over on router 1. And I'm going to go and first off remove this one from being applied. Exit back out. So matter of fact, let's just kill the whole thing. I'm going to do a no access list 1. And it's gone. So that actually deleted the whole access list. I'll do a show IP access list, and you can see nothing there. They're all gone. So let's go in and create. So I'm going to create access list. We can use 1 again, but just because I want to be different, let's use 2. So access list 2. Now, who are we denying? We are denying this whole subnet, 192.168.2.128, with that weird subnet mask. So again, we're looking at that range, 192.168.2.128 through 255. Okay. So I want to block that whole subnet. So I'm going to say, okay, so 2, I'm going to deny. That's my goal, is to block them. And it says, okay, what address do you want to match, or do you want to do any address or a specific host? Well, I can't use any because that'll block everybody, and that's not the goal. I could use host, but that means I'm going to have to type in host 192.168.2.128 and then hit the up arrow 129, 2.130, 2.131. Come on, is this efficient? Can we say can I hear a no? No, it's not efficient. So I mean, we're creating this show giant access list, show IP access. You see all these. It's just crazy, but so I'm going to say no, clear access list 2. So let's blow it away. So we could do that, but not efficient. So instead, I'm going to say I want to block the network 192.168.2.128, but enter stage left the wildcard mask. Okay, wildcard mask allows you to say these are the bits that I care about. Now, nobody is really certain why Cisco decided to go this way. Like you would think it'd be nice and logical to be able to say, okay, well, block that network like that. But a card mask doesn't do that. Think of some, I mean, if you've got a rebellious teenager, and you're like, man, they're wild. What do you think? You're like, okay, they are doing the opposite of what I want them to do. They are doing the opposite of what would be acceptable and normal to this family, right? So think of the wild card mask. It's the rebel. It's the opposite. So it's going to be the backwards mask, essentially. So we see the mask as 255.255.128. The wildcard mask is exactly the opposite. Flip it. As in, if we were to look at this in binary, 1, all the way down to, .1000000. So that's the normal subnet mask in all binary. Wildcard mask flips it. So wherever you see a 1, put a 0. Wherever you see a 0, put a 1. So the wildcard mask would be 0.00000.00000.0.0111111. So take that in all binary and then flip it as exactly the opposite, and there you have the wildcard mask. They are the weirdest looking things ever. So the question is, what is that? What is that binary number as a decimal? Well, that's where you pull out your mathematical mind and add 1, 2, 4, 6, 8, 16. Did I count that right? 32, 64. Right? That didn't feel right, but you know what I mean. You add all the binary digits up to 64 together, in one big math problem, and that will give you, if you add them all up, 127. So the wildcard mask, instead of being nice and easy as a subnet mask, I go in there and I say, actually, it's going to be 0.0.0.127. Creepy. That's it. That's the accurate way of identifying I want to block that whole network. Now I've got a shortcut for you. Doing it in all binary, it's kind of painful. So what I usually do if I'm like, okay, what's the wildcard mask? I take all 255 and subtract my subnet mask that I want to kind of convert over to a wildcard mask. And that will give me, obviously, easy math there, and I go 127. That is the wildcard mask for this subnet mask. /25 or 255.255.255.128. That's the opposite. So again, nice and bizarre. That's probably the most difficult thing of access lists, next to figuring out which direction to apply them, is going, okay, what's up with this wildcard mask? Why would I? So let me ask you this: what would the wildcard mask be for this? If I were to generate a wildcard mask for 192.168.1.0/24, what would it be? It'd be, we say, okay, deny or permit 192.168.1.0 with a wildcard mask of 0.0.0.255. That's the flip opposite of a /24. And the way to think about it is, if you like looking at things in terms of decimal, wherever you see a 0, that tells the router, look at this. Evaluate this. This access list is either permitting or denying. So when this packet comes in, look at this. Look at the 192. And then it goes, okay, a 0. That means look at this. 192.168. A 1. Look at this. Make sure that you're watching this. And then this last one, it's like, I don't care. Essentially, the 255 or all ones says, I don't really care what's in that last octet, and that's good. So if I have an access list that's saying deny 192.168.1.0, this guy's 192.168.1.50, and it's going to come in and say, okay, you're 192. I look at that. And then it's like .50. Well, I don't really care about that. Whatever, so you will be denied because you start with this. So it's really like, what are you matching on with this? You could. You wouldn't do this, but you could. You could do something like, I want to create an access list entry that says I want to match 192.0.53.0 with a wildcard mask of 0.255.0.255. And what that says is, let's just say we said deny, and then we put that information. That's saying, okay, I'm going to deny any IP address that has 192 in the first octet. I don't care what's in the second octet, but they also have to have 53 in the third octet, right? Because that's a match. This one, I don't care what's in the last octet. So you could actually deny things based on, just one octet. Okay, let me ask you this. What do you think? Let's say I want a wildcard mask that would deny everything all the time. What would it look like? I would say deny the IP address. I would just put 0000. It doesn't matter what you put there because it's not really caring about it. Wildcard mask 255.255.255.0. Or sorry, not 0. 255.255. I've said that too often. 255.255.255.255.255. It's very much saying deny. I don't care. I don't care. You're denied. Doesn't matter what IP address you have. You could also go the other way. For instance, let me show you. Let me show you this. Remember we did that access list. Let me just use access list 50 as an example, and I did permit. And like in that first example, we said host, 10.1.1.1, right? A different way of doing it, I said there's a couple ways you can do it. A different way of doing it is I could have said permit 10.1.1.1, but now it's going to ask me for a wildcard mask, so I would put 0000. Now watch this. I'll do a show IP access list. Access list 50, it's automatically dropped that because it assumes the host command. I could have done the same thing. I could type in access list 51, permit host 10.1.1.1, hit the enter key, show access list. Look, they're one and the same. One, I use the wildcard mask of all zeros. One, I use the host command to type that in there, and it ends up being the same thing, the same result. So back to the example, we were using access list 2 up here, and I said deny 192.168.2.128 with a wildcard bits 000.127, right? So that's the opposite of that subnet mask. Okay, that's great. And I'm going to want to come back. Good grief, I've got this thing's a mess now. I'm going to come back in here and I'm going to apply that outbound. But before I do, remember an access list with only a deny command will deny everything because of the implicit. So I need to go in there and do access list 2 permit any. And let's get rid of the other ones. No access list, my little demo access list 50 and 51. They're gone. So show IP access list. And now I've got a cumulative access list. So I've got deny 192.168.2. Okay, that looks good, and permit everything else. So now I need to apply it. And since this said only, let me just get rid of all this chicken scratch. Only deny access to this one network. That's my focus. I'm going to go into the router. I'm going to say, okay, show IP interface brief. And I'm going to look at me. Oh, well, that's the network I want to block access to. I don't want 192.168.2.128 to get there. So I'll go into fast Ethernet 0/0 IP access group 2, because that's the access list I created right here. Number 2, right? And then out. So as this network tries to go out fast Ethernet 0/0, I'm going to deny them. So let's give it a try. I'm going to shoot over to router 3 first, just to make sure. I'm going to do a ping 192.168.1.50, and it works. Now don't be surprised. You're like, well, I thought, but didn't we deny that network? Yes, but router 3 is not that network. Router 3 came from this IP address, 10.1.1.1. That's the IP address I pinged from. So the access list came in there. Matter of fact, let's verify it. The access list said, well, 10.1.1, come on in. So I'll do a show IP access. I'm seeing matches. Those pings were, come on in. You can feel free to come in. But let me show you something else. Let me first off do the PC. I'm going to go to PC3 up there, which is right here. Okay. So PC3 is right here. So I'm going to do a ping. Let's do a ping 192.168.1.50, which is that host over there. Hit the enter key, and sure enough, I'm getting unreachable messages back. And those U's are a sure indicator that you've done it right. But if you want to feel that warm and fuzzy feeling, you can do a show access list, and now I can see I'm getting deny packets from that access list. The other thing I wanted to show you is I said router 3 is not coming from this network, it's coming from this, right? Well, watch this. If I want to, I can make it come from that network. Want to see how? I'm going to go to router 3. And I'm going to type in ping. That one works fine. It's coming from the normal one. So I'm going to hit the question mark after the ping command. And I'm going to say I'm actually coming from the source IP address. And I can either type in my IP address, where I type in 192.168.2.129, or I can type in the source of fast Ethernet 0/0. And sure enough, now take a look at this. It says I'm sending 5 pinks to that guy with a source address of 192.168.1.129, which is right there. And you can see, sure enough, those are all denied by the access list. That's pretty cool. Okay, last example. And first off, at this point, you should feel a little more warm and fuzzy about doing this. So you might just want to pause and write this up on paper or try it out on a router if you have one, and see if you can figure that out. But I'd like to use this last example to illustrate an example of using named access lists, which I love far more than the numbered ones. So it says create a standard access list to block 192.168.2.50. It's this one. From reaching 10.1.1. That's this one. So block them from getting there. So looking at that, I could think, okay, well, I could either apply it outbound right here, and say this guy is blocked from getting there, or I could apply it inbound right here. Now, basically, regardless of which one you choose, the result is going to be the same. I'm not going to be able to reach this, but also by saying block to this WAN IP address, I'm going to automatically be denied from reaching that network too. Why? Because standard access lists can't say what you're denied from. They just say you're denied. So when I say deny 192.168.2.50 and apply it either out right here or in right here, that access list is going to say you are denied. You are denied from getting any further. So honestly, I would think it might be a little more efficient to apply it out right here, because otherwise you have to cross the whole WAN link just to find out on the other side that it's denied. It's like a bad trip to Disneyland. You got to drive all the way to California just to find out Disneyland is closed for the day or something like that. So you don't want to have these packets drive further than necessary. So in this case, since the result is the same, I'm thinking applying it outbound right here would be the best way to go. So let's do this. I'm going to get into router 2. Haven't even been on this one yet. And let's go into global config mode. So now let me show you. So far we've been using numbered access lists, which is done by typing in access list and a number, whatever number we want to pick what kind. But the better way, I believe, it's a lot cleaner, or it just makes more sense, is to type in IP access list. Okay, it's same thing that we're after, an access list. It's just putting the IP keyword in front of it tells it I'm going to create a named access list. So notice, instead of asking me for a number to identify what kind it is, it's just asking me. It's like, hey, why don't you just identify what it is? Is it a standard or is it an extended access list? Now, all these other commands is like, okay, do you want to renumber it? Do you want to set up logging or a log update? But really, the main commands is standard or extended. Well, right now we are creating a standard access list. So I'll type that in. It says, well, you can even use this command to modify one of the numbered, or now I'm going to give you the option to type in a named. So I'm going to say block PC2 ACL. I put little underscores in between. You can't put spaces. But do you see how that makes more sense when I do a show access list? If I see block PC2 ACL, matter of fact, it's going to bug me. Hang on. I want block PC2, no underscore there. So block PC2 ACL. Now when I do the show command, I can see exactly, just by looking at the name, I know what it is, rather than being like, oh, what was number 73 again? You have to have some kind of reference for that. So I'm going to say, okay, I want to block 192.168.2.50. So the way this works is it's just as if I had typed IP access list. Or access list, whatever I want. Now I can say permit or deny, or I can even use a sequence number. Now you saw that by default, so far, when we type in create an access list, it creates sequence numbers of 10, right? The first command we typed in, it says sequence 10. Next one, sequence 20. Next one, sequence 30. Now, if you want to, you can type in your own sequence numbers. I can say sequence 100. And then type in permit or deny or anything like that. Or if I just type in permit or deny without typing in a sequence number, it will automatically use that increment of 10 for me. So I'm good with that. So let's just say deny. I want to deny 192.168.2.50 wildcard bits 0000. And then again, I've got now an access list with just the deny. So I'm going to say permit any. So I'm going to go back and do a show access list. And now I can see I've got access list. Don't you love the name better? Block PC2 ACL. Same syntax as before. Sequence 10, deny that host. Sequence 20, permit everything else. So now I can go into interface serial. Let's see, we're serial 0/1 on that side. Network diagrams are essential for this. And do IP access group. And now I'll just type in the name, block PC2 ACL. By the way, keep in mind, this is case sensitive. So if you use lower uppercase, you gotta keep it consistent. I always type them in all uppercase because it's easy for me to see in a show run. And then I'll hit question mark, outbound. Playing it out that serial 0/1 interface. Good. So now I'm going to test it. Got to be sure that it works. Let's go to PC2. And I'm going to ping 192.168.2. Well, actually, the goal was to block it from 10.1.1.1. So let's start there. Make sure we achieved our goal. And sure enough, I'm getting those unreachables, show access list. I can see that I'm denying that host, so it is working. But also, just as a bonus, because with the standard, there's no way of stopping it, I'm completely denying access to everything beyond that WAN interface as well, because it's just saying you are denied, period. With access lists, as I said, the more and more you do, the better and better they feel. What I would like you to do is, first off, if you have your own router or something like that, use that to practice the syntax, to come up with those scenarios. Matter of fact, you could just run through the scenarios, just bring up the slide I've been using this entire time, pause it, and now see if you can do those 3 examples on your own without actually watching me walk through that. Then I would start going through and coming up with your own scenarios. Come up with I want to deny this from this and try it out. I'm going to make that GNS3 topology available to you. So if you have GNS3, if you've played with that, maybe you check out, I think CBT Nuggets even has some free GNS3 videos that you can download if you don't have access to the whole thing that will at least show you how to get started with it and so on. It's, again, free emulator software that you can use. Import that topology and start practicing with the environment that I've created right there. So once you're feeling pretty good about standard access lists, go ahead and jump into the next one, which is going to be the extended world. I hope this has been informative for you, and I'd like to thank you for viewing.